to be talking again about acid-base reactions, more detail about pH. This is what our exam is over tomorrow. Chemical reactions, so reactants and products, balancing chemical equations. We spent 2 days balancing chemical equations. I'm going to tell you there is a question on the test tomorrow where you are going to be expected to balance a chemical equation. So bring a piece of paper, bring a pen to the test tomorrow because you're going to have to do that. And then molar mass, solubility, and then we wrapped it up with acids and bases. Okay. So today we're going to define pH, explain how we can tell a specific pH, talk about neutralization reactions, and talk about buffers really quick. So go ahead and open up your notes for today. They are 4G, acid-base reactions, and pH. Okay, and then click OK on question number 1, just that you understand that for the summer term, there is no participation points, there is no attendance points, it's only daily work and your exams. Okay, thank you, thank you, thank you. Thank you, Ayani, Australia, Jesus, Jordan, Cody, thank you, Michaela, Danny, Lamont, Ryder. How's it going, Randy? Kaylin, thank you, Jesse. Alex, you good? Ready, ready, ready? Sweet. Okay. With that, let's do this, okay? So when I talk about pH, okay, pH is a scale, okay, and notice that pH actually goes from 0, which is the most acidic, the strongest or highly acidic, all the way to 14. And 14 is the most basic, highly basic, okay? And that means this in the middle, pH of 7, pH of 7 is neutral, okay? Anything less than 7 is acidic. Okay, anything less than 7 is acidic. Anything greater than 7 is basic. Okay, so if you have a pH of 6, it's only slightly acidic. If you have a pH down here of 1 or 2, it's highly acidic. Okay, same thing on the other side with bases. Okay, if you have something that's a pH 8 or 9, that's only slightly basic, whereas a pH of 13 or 14 is highly basic. Okay, remember that acids donate hydrogen cations and bases donate hydroxides to water. Okay, so with this, you have question number 2 right here. Okay, I'm going to give you your annotation tools, and I want you to match these different solutions to, if it's highly acidic, slightly acidic, neutral, basic, or highly basic. Again, look at their bases, okay? Look at their pHs. So here's pH 7.4, here's pH 2, pH 5, pH 12, and pH 7. The scale goes from 0 to 14, right? Yes, Human blood is slightly basic. Water, pure water, has a pH of 7, and that is neutral. Exactly. Yeah. Gastric juices, the hydrochloric acid that you have in your stomach is highly acidic, whereas your urine is only slightly acidic with a pH of 5. That means bleach is highly basic. Great job. Excellent. I'm so proud of you guys. Yeah, exactly. So this is question number 2. Question, double check, make sure you got all of those answers. Okay. Thank you, Michaela, Lamont, Ryder, Danny. Thank you, Ayani, Australia, Cody, Jesse. Thank you, Randy. Thank you, Kaylin. Jesus, Jordan, Alex, you doing okay? Perfect. Thank you, thank you, thank you. Thank you, Jordan. Thank you, Jesus. Thank you, Jesse. Awesome. Perfect. Okay. Now, so when we rank pH, right? You remember we talked about litmus paper yesterday, and litmus paper doesn't tell us the exact pH, right? It just says, yeah, it's an acid, or no, it's a base, right? I know that if I'm using litmus paper, if both if red litmus paper stays red and blue turns red, then it's an acid. I also know that if blue stays blue, red turns blue, then it's a base, right? If the different litmus papers don't change colors, red stays red, blue stays blue, then it's neutral, right? But there's other indicators that we can use that gives us very, very specific pHs, okay? So one of these is a pH, using pH paper, okay? Let me grab there it is. Okay, so here is a video clip of how to use pH paper, okay? Okay, so you can see using pH strips are pretty easy. You just take the strip of paper, dip it in your solution for a couple seconds, pull it out, and then you have a key that you match it up with, right? Notice that well, let's talk about the first solution, right? The first solution that he made, it was highly acidic. It was much closer to a pH of 1, because you can see it was kind of pink, right? Than it was to any of the blues, which indicate it's a base, right? The second solution was highly basic. It was a very dark blue. Now, the third solution, this one, okay, he said it was neutral. And this color right here is neutral. It's sort of a green with a little bit of like a pea green. I don't know, whatever you want to call it. But if you look at the pH paper that he used, the pH strip, you can see it's probably closer to a 6 than not. And the reason for that was he was measuring drinking water, right? Water out of the tap. When I say that water is neutral, it has to be pure water, nothing else in there, no fluorine, no chlorine, nothing out that you'd see in your tap water, okay? It would have to be a deionized water. And that's why his drinking water was slightly acidic, okay? So again, you just dip the paper in and you match it to your key, which brings us to question number 3, okay? Question number 3, you on your notes have a piece of paper, a pH that has been dipped in a solution. You need to identify, is it highly acidic, slightly acidic, neutral, slightly basic, or highly basic? What do you think? And again, you can go back and look at question number 2 that has different pHs on there to help you kind of identify what you think it's closest to. Good job, guys. Excellent. Woohoo. Thank you, thank you, thank you. Thank you, Yanni, Jesse, Australia. Thank you. Danny, Lamont, Ryder, Randy, Michaela, Kaylin. Thank you, thank you, thank you. I appreciate you guys. Thank you, Dulce. Jordan, Jesus, Cody, Alex. What do you guys think? Thank you, Jesus. You rock. Okay. Yay, Jordan. Alex, Cody, you good? Okie dokie. Woohoo. So that's question number 3. Now, neutralization reaction. When I mix an acid and a base, I have a neutralization reaction, and it's going to create a salt and it's going to create a water, okay? Any neutralization reaction that occurs always makes a salt and a water, okay? So if I mix a strong acid and a strong base, okay? If both of them are strong, okay? Both are strong. Then I'm going to form a neutral salt and water, okay? So if they're both strong, that means that they are both corrosive and both are very, very dangerous. That's going to create a neutral salt, neutral water, and a neutral pH. Now, what happens though if they're not both strong? What happens if one is strong and the other one is weak, right? So for example, if I have a strong base and a weak acid, right? Well, what I want you to do is think about who's going to win if you've got a strong something and a weak something, right? Well, of course, the strong one's going to win, right? So that means I'm going to end up with a basic salt if I have a strong base and a weak acid. If it's flip-flopped, if I have a strong acid and a weak base, then again, who's going to win? Whoever is stronger is going to win, right? So this is going to result in a acidic salt and water, okay? So that is a neutralization reaction, okay? Strong and strong makes a neutral salt and water. A strong base and a weak acid makes a basic salt and water. And then strong acid, weak base, I'm going to get an acidic salt and water, okay? So with that, I'm going to give you these annotation tools, okay? And I want you to match up the neutralization reactants that are on the left with the product, which is on the right, okay? What do you guys think? Yeah. Neutral salt. A strong base is going to win, and you're going to get a basic salt. And then that strong acid is going to give you an acidic. Yeah, exactly. This is perfect. Thank you, thank you, thank you, thank you. Okay, I'm going to give you 20 seconds to go ahead and do this question. This is question number 4. Question number 4. Jaden, hey, glad you're here. Hello. We're working on and this is question number 4. Okay, so go ahead, get your notes open, do question 4. I will wait for you. Give me a thumbs up when you are ready. Okay. Thank you, Dulce. Thank you, Danny. Thank you, Ryder. Thank you, Jaden. Thank you, Australia. You guys rock. Okay, I think we're good. Perfect, perfect, perfect. Okay, so now a buffer. Okay, a buffer is a solution that, thank you, Kaylin, that resists pH change. Okay, so a buffer, if I use a buffer and I add lemon juice, it's going to kind of fight back against that lemon juice, and it's going to help maintain a little bit of a constant pH, okay? And they help bring that pH closer to 7 by neutralizing the acid or base that's being added. So that neutralization reaction that we were talking about occurs, okay? So a buffer is made up of a weak acid and a weak base, and it just helps keep the pH kind of stable. Thank you, Ryder, Randy, Lamont, Michaela, Danny, Kaylin. Thank you, thank you, thank you. Agani, Alex, Australia, Jaden, Jesus, Jesse, Cody, thank you. Dulcie, you good? Yeah? Sweet. Thank you, Jordan. You guys are amazeballs. Perfect. Okay. Now, remember that these buffers, right? They're just going to neutralize whatever acid or base that is being added. And it's just going to kind of neutralize it and keep that pH stable. And that's really, really important, especially body. If we didn't have body buffers, then horrible things would go wrong in our body. For example, right? Protein in your blood binds excess hydrogen oxide or hydronium ions during exercise. And this is right, lactic acid. It's producing lactic acid. And you need a buffer to keep your blood in the pH range that it needs to be in. During respiration, when I'm breathing in and out, okay, my pH changes when there's too much carbon dioxide. And then it starts forming carbolic acid in my lungs, and that's not good. So I need the buffers to kind of stabilize my pH in my lungs. And then, of course, again, right, our urine is slightly acidic. But our kidneys need to be able to balance that and get rid of acidic or the basic urine, right? So very, very small margins of error in your body. And that's why we've got so many buffers in our body. Okay. Thank you, Yanni, Alex, Australia. Jesus, I appreciate you. Thank you, Jesse. Thank you, Jaden. Thank you, Kayla, Michaela, Randy, Lamont, Ryder, Danny, Jordan. Thank you, Cody. Awesome. They'll say you good? Yeah. Easy peasy, right? Yeah. Sweet. Have you ever taken an antacid? Have you ever had a or heartburn, right? Antacids neutralize the excess stomach acid. But remember, your stomach's supposed to be acidic, right? So even though your antacid helps neutralize your stomach acid when there's too much stomach acid, it also includes some buffers in there so that your stomach doesn't become too basic and throw off your metabolism. Okay, so Tums, Rolade, Pepsid, all of those things. Okay. Thank you, Alex, Yanni, Cody, Australia, Jaden, Jesus, Jesse. Thank you, Kaylin, Michaela, Randy, Lamont, Danny, Ryder. Jordan, you doing good? Thank you, Dulce. Thank you, Jaden. Yep. Yep, Dulce. You got it. Okay, now we are going to use Wayground to finish our questions 8 through 21. But before we do that, before I turn you loose and give you those links, remember that we've got an exam tomorrow, which is 13% of your grade. Come to class tomorrow, get that done, get that turned in, get a good grade. And then remember, Friday is a work day, right? It's for anybody that needs to bring up their grade. All missing work, late work is due at 11:59 p.m., which is just before midnight. Okay, so we are going to do way ground. I'm going to share my screen. I'm going to show you what it looks like, right? Okay, so is the one you are going to want to do, acids, bases, and P. It's going to give you a little bit of a lesson. And then it's going to give you a question. Which of the following methods is used to indicate the concentration of hydronium ions in a solution? And I know that is pH scale. And if I were to click on this, right, it would tell me if I'm right or wrong. And when I do that, then I can answer question number 8, which says, which of the following methods is used to indicate the concentration of hydronium ions in a solution? And lo and behold, I know my correct answer here, right? So use your way ground to help you get the correct answers for the rest of the notes. Okay, so I have just put the link in there. Okay, and you can use that, or you can use this one. Okay, either one of those. Okay, and then when you are finished, submit your 4G notes, and then it's just going to be a work day. Okay, but finish your 4G notes first.